Okay, question 12. 12 is, again, 3 equation, x minus y plus 4z equal 1. Equation number 1, 4x, y is missing in this equation, plus z equals 0. Equation 2, and minus x plus y minus 4z is equal negative 5. Equation 3, and this is our system. Okay, for solving that, I propose you pair equation 1 and equation 3. X minus y plus 4z equal 1, and negative x plus y minus 4z equal negative 5. And when you try to apply elimination, you see this part is elimination, eliminate, 0 is equal negative 4. Again, at least when you have one contradiction, the interpretation of this system have no solution. This system is inconsistent. Que corresponde en our handout. Let's see, let me try to find. It's question 12. Option D. Option D, inconsistent. No solution. Okay, this is equation 13. For example, in this case, I propose pair equation 1 and equation 2. Let me copy. 2x minus y plus 5z equal negative 7, and x plus y minus 2z is equal minus 2. Okay, when you're adding, this is 3x. This part cancel out. It's plus 3z equal negative 9. Okay, in this equation, if you divide by 3 this equation, you have x plus z equal minus 3. This is equation 4. Now you pair, suppose you pair the equation number 2 and the equation number 3. So you have x plus x, 2x. One more time, cancel out y, plus 2z, because 4 minus 2 is 2, equal negative 6, divided by 3 again, divided by 2. This equation is x plus z equal minus 3. And this is equation number 5. And you see the equation number 5 and the equation number 4 are exactly the same. It's obvious then that we expect infinity many solutions. Okay, suppose that I don't see very well this idea. If you multiply the equation number 5 by negative 1, now we have negative x minus c equal positive 3, and when you're adding this and this is cancel out x, cancel out z is 0, equal, and 3 minus 3 is 0. This system is true. That means that we expect infinity many solutions. Now for finding the solution set, okay, obviously is the solution set that contain infinity point on the line. for example, here, I suppose assume that z is free variable. Therefore, x is equal, so for x here is -3 minus c. Okay, and likewise, see, I'm using, for example, the equation number 2. This equation, let me see this equation. I'm using this equation. So I'm using equation number 2. In principle, we can use either equation, but suppose okay, using this, instead of x, I replace this -3x, -3 minus c plus y minus 2c equal -2. Okay, we combine like term, -c and -2c, -3, so we have -3 minus 3z plus y equal -2. Therefore, isolate y. Y is equal -2 plus 3 plus 3c is equal 3c plus 1. Okay, ready to write the solution set. Solution set for our system is infinity many solution, of course. Solution set is infinity many solutions. All the point in the 3-dimension space, 3-dimension context, such that x is equal -3 minus c, comma, y is equal 3c plus 1, and c is free variable, is all real number. So one more time, the dimension of this solution is 1, because we have one free variable, and this represents a line in 3-dimension context in R3. Okay, question 14 is a system, but in this case, this system is underdetermined because we have 2 equations and 3 variables. So we have more variable than equation. So in this case, we have only 2 possibilities. We have no solution or infinity many solutions. In this case, it's impossible to have unique solution. So unique solution, no, it's impossible because it's underdetermined system. Okay, so now I propose, for example, multiplication the first equation by -5, and multiplication the second equation by +4. The strategy is clear because -5 times 4 is -20, and 4 times 5 is +20. So it's ready for elimination. So you copy 2x, 2x, no. You multiply 5, -5 times 2 is -10. So I multiply the entire equation number 1 by -5. Minus 2y minus 20y, this was the idea, plus, because negative times negative is positive, thing z is equal to 0. I multiply the second equation by 4. We have 12 x plus 20 y is equal 4, because 4 times 1 is 4. Okay, ready for elimination. In this case we have 2x. This part is cancelled out. That was the intention. Bring down 10z equals 0 plus 4 is 4. If you divide it by 2 this equation, because I want to simplify a little bit, this is x plus 5z is equal to, okay. Entonces, in this case es obvio que we cannot get the contradiction, no contradiction. Entonces, no solution is discard. Entonces, we have infinity many solution. When you have infinity many solution, we need to define some a free variable. Entonces, I assume supposition que z is free variable. Okay, now I solve for x is equal 2 minus 5z. Okay, I want to determine then the relationship between y and z. Now I propose using either equation. I take the easier equation, for example, number 2 equation. Thus I have 3 parentheses multiplication 2 minus 5z plus 5y. Go on. Now apply this through the property here. 6 minus 15z plus 5y equal 1. Let's solve for y. 5y is equal 15 positive z on the right hand side plus 1 stay on the right hand side minus 6. That's equal 15 z minus 5. Finally divided by 5, everything 5, 5, 5. Y then is equal to 3z minus 1. Okay, and this is another relationship between y and z. Okay, now write the final answer. Okay, one more time, solution set. Solution set is infinity many solution, but the context is 3-dimensional context because we have 3 variables, such that the relationship between the variable is, okay, x is equal 2 minus 5z, comma, y is equal to 3z minus 1, and z is free variable, que is all real number. One more time. You have a one more time we have a infinity many solution. Dimension of our solution set is 1. It's a line in 3-dimensional context because we have only one free variable. Okay, question 15 is super easy equation. It's just introduction for the matrix notation. Entonces we have a 16. The base idea is write the matrix notation. Entonces you write a big bracket, and inside you put the coefficients. Organize in this by column or by row, doesn't matter. It's 6, it's 4, it's 3, it's 7. This column corresponds with the x. This is the organization. The second column corresponds with the y. The third column corresponds with the z. And you put the line to separate the coefficients of the variable x, y, and z, and the right hand side is just a number. It's 66, 68, 51, and 3. Okay, and this is the matrix notation. And by the way, let me take advantage to see what the dimension of this matrix. This dimension is, we have 4 rows, 1, 2, 3, 4, by 1, 2, 3, 4, 4 by 4 column. Okay, that's it. It's super easy. This corresponds with the option B, and they have that. Okay, question 16 is exactly the same. It's basically write the matrix associated with the system. You open big bracket. You copy. By row, I recommend by row. 3, 9, -5, and 1. Because 1 is the coefficient here, invisible 1. Now put the line in the right hand side, we have 5. Okay, so each equation corresponds, this equation corresponds to this row. And the second row, because the second equation, we have something missing. We have no coefficient of x, 0 then. 6 and y, 1 and z, and no w, -2 in the right hand side. The third equation, we have coefficient 1 in x, -1 in y, -10 in z, and no in w. In the last equation, we have 12 in x, -12 in y, 2 in z, and no again in w, and 11 in the right hand side. And this is a matrix. Associate, in this case, the dimension is 4, because we have 4 equations. It's 1, 2, 3, and 4 equations. By 1, 2, 3, 4, 5 columns. And that's it.